divide polynomials, and subtopic is polynomial division. So we're going to use polynomial division to determine factors of polynomials. When you graphed polynomial functions in the first section of this chapter, you learned that the factored form is useful for determining the zeros of the function or the x-intercepts of the graph. But when you do not have the factored form, what happens when you need to list all of the zeros or x-intercepts? You will investigate the answer to this question in this lesson. Question 84 says, Andre needs the exact x-intercepts of the function x to the third plus 2x squared minus 7x squared minus 2. When he uses his graphing calculator, he sees that one of the x-intercepts is 2. But there are two other x-intercepts he can't identify exactly. Maybe they're not going through a number perfectly, right? So it's kind of a little to the left or a little to the right. What does he need to be able to do to determine the exact values of the other x-intercepts? Andre remembers what he learned, how to multiply binomials and polynomials using an area model. He figures that since division is the inverse or the undo operation for multiplication, he can reverse the area model multiplication process to divide polynomials. As he is thinking about this idea, he comes across the following news article. Polydoku, Craze, sweeping the nation. CPM, that's the company that produces our curriculum. Math enthusiasts around the nation have entered a new puzzle craze involving the multiplication of polynomials. The goal of the game, which enthusiasts have named Polydoku, is to fill in squares so that the multiplication of two polynomials will be completed. The game shown at right, for example, represents the multiplication of 3x minus 2 in orange and 2x to the third minus x squared plus 3x minus 1 in green is equal to the polynomial 6x to the fourth minus 7x cubed plus 11x squared minus 9x. I think that says plus 2, okay? That's the full polynomial that we're going to get. Most of the squares are blank at the start of the game, while the beginner level provides the factors in the gray squares. Some of the factors are missing in the more advanced games, okay? So the first couple that they're going to give you are going to have a few missing, and then as they get harder, there's going to be more missing, okay? But basically, on the left, you're going to multiply that term by a term at the top, and it's going to be equal to the box that's inside that corresponds to the column and the row. So for box 2b, the 6x to the fourth, you would multiply 2a times 1b. So 2x to the third times 3x is 6x to the fourth. Everybody see how you get 6x to the fourth? Okay, makes sense. So each of the boxes across this top row are going to multiply by the boxes on the side and get the boxes in the side. And then how do you get this answer at the bottom? You're going to combine like terms. So there's only 1/4 power, you just write. There's 2/3, you combine. There's 2x squared, you combine. There's 2x to the first, you combine them. And then there's only one constant term, so you just rewrite it, okay? Does it basically make sense? Everybody have the basic concept? Okay. All right, analyze. It says analyze the game of Polydoku. How can Andre use the game to determine other x-intercepts? You would set the factors equal to 0 and solve. Andre could use x minus 2 because he already knows that one of the intercepts is 2. So he could take this one, or he could take the x minus 2 and use it to solve that one right there, because that's not the same one. It's that one, but way back up here. Okay? So I think they have us do that one on the next page. Let's see. Anybody still writing? All right, go ahead and turn it over to the top of page 23. Question 85. Andre decides to join the Craze and try some Polydoku puzzles, but he is not sure how to fill in some of the squares. Help him by answering parts A and B below about the Polydoku puzzle. In the news article he read, found in problem 84, then complete part C. Okay? So part A, explain how the term 2x squared in cell C3 of the news article was generated. Okay? So you would take the term on the left and multiply it by the term that's above box C3. So one of them was negative 2. One of them was negative x squared. Negative times a negative is a positive. 2 times 1 is 2. And the x squared. Okay? For part B, what values were combined to get negative 7x to the third in the news article? Okay? So there were 2 cubed terms. One was negative 3x to the third, and the other one was negative 4x to the third. Those two combine to get negative 7x to the third. Okay? So for part C, they want us to complete the Polydoku puzzle on the right. Okay? All right. So for each of the boxes, we're going to multiply above and to the left. So for box 2B, we would multiply 4x to the third times 2x, which gets us 8x to the first. You multiply the coefficients, you add the exponent. You can't see the exponent. There's a 1 there, right? This one has a 1. If there's no x term, you don't add anything, okay? Or like this one. There's no x term. So when you multiply negative 3 times 4x to the third, you get negative 12x to the third. Okay? So you fill in all of these boxes first. And then to get your answer, you're going to combine any like terms. 8x to the fourth is the only fourth power. It gets to stay by itself. The x to the thirds happen to be opposites. That sometimes happens. You can write 0x to the third if you want, or you can just not write it at all. Okay? You just leave a blank spot there. The x squareds combine, the x's combine, and then the constant term doesn't have anything to combine with it. Okay? When we're done in your groups of 4, you're going to come back and do 86 and 87 together. So 86 says, work with your team, complete the puzzle at the right. What are the factors and the product for the puzzle? If you get stuck, you can consult parts A through C below for ideas. And then number 87 says, Jessica is about to start the intermediate level Polydoku puzzle shown at right. Show Jessica how to complete the puzzle. Make sure to justify your solution. Okay? So this one has the answer, has the ending polynomial. You need to determine what is the trinomial that is going to get that. Okay? So if you took the huge polynomial, divide it by the binomial right here, you're going to get an answer in boxes 2A, 3A, and 4A. That's going to go right here. 2x plus 5, you already know, times whatever's there, is going to be equal to your answer. Okay? Flip over to the top of page 24. And even though we haven't done question 87, you're gonna see what happens when there's a remainder. Okay, so unfortunately, Jessica made a mistake when she copied the puzzle for problem 87. Constant term of the original polynomial was supposed to have a value of plus 18, but she accidentally wrote plus 10. We've all done it. We've all wrote the wrong number sometime, right? She does not want to start all over again to solve the puzzle. Jessica realizes that she now has 8 remaining from the original expression. What is the significance of this 8 in the relationship to the division problem? 8 is going to be your remainder. Okay? We'll have leftover. Like, you guys remember doing long division in elementary, like 4th and 5th grade? Okay? That's your remainder. You're going to have remainders on some of these. So you'll get the trinomial. There'll be something left over. It could be positive. It could be negative in some cases. Okay? Gina thinks that there is a way to write the answer without using the word remainder. Discuss with your team and write the result another way. I don't know if you guys ever learned this, but you can write remainder 8, or you can write plus 8 over the divisor. You seen it that way? It's commonly accepted. So you can either write the word remainder, or you can write it as that fraction. Okay? So let's see one with a remainder, as in part C. Okay? Use Jessica and Gina's method to divide the 6x cubed plus 11x squared minus 12x minus 1 by the 3x plus 1. So we fill the 3x plus 1 in here. I'm writing the quotient down here. And we need to figure out the rest of it. Okay? To get 6x cubed, what would you multiply 3x by to get the 6x cubed? You would need to multiply it by 2x squared. So you would be determining that number right there. So the 2x squared times 3x would give you the 6x cubed. Once you've determined this term, you can then take that term and multiply it by this term to get that box. Because then you know the 2x squared, so 2x squared times 1 would be 2x squared. Then you look at the next term, and you say, I need something to add with 2x squared to be 11x squared, and that would be 9x squared. Because 9x squared plus 2x squared is 11x squared. Does that make sense? So what would you multiply 3x by to get 9x squared? That would be 3x. So you're going to use the previous answer to work your way across. Okay? So let's jump to right here. What do we need to combine with 3x to get negative 12x? That would be negative 15x, which makes this a negative 5. So negative 5 times positive 1 is negative 5. But we needed it to be negative 1. And it's not negative 1. The difference between negative 5 and negative 1 is our remainder of 4. That's how you get the remainder. So when you get to the end, if this number and this number are different, that becomes your remainder. Okay? Everybody's looking at me like, oh, okay, you'll have to try one. It's when I do it for you, I make it sound so easy, but you guys will have to try it on your own. We're gonna do 89 together. We're gonna skip C and D, and then that's it. Okay, so for 89, it says, create your own Polydoku puzzles that can be used to solve each of the polynomial division problems below. Express any remainders as fractions, bless you, and use your results to write a multiplication and division statement like that in problem 88.